Hi, everyone. This is Jules Urbeck. I'm the CEO and founder of OTOY, and we're very proud to present the future of GPU rendering, our GTC 2020 talk. It's funny. This is actually my 10th GTC, and back in 2010, I presented what we were doing, our GPU roadmap, for the very first time, talking about GPU rendering in the cloud, many other things. But it's an incredible thing to think about the last 10 years and how far we've advanced. And GTC has always been a big part of that for us. We've invested heavily into putting out what we think the future is going to be like at these events. Here we are at 2013. And the last 5 years, I started to bring in other things into our discussions, talking about how we see the holographic future happening, how holographic display panels are going to come into the industry. And so it's interesting to really look at the last decade of GTCs. And it's exciting to have our 10th GTC be in such an interesting moment with Raytracing hardware and AI and many other things that are now a huge factor in what we're doing in the GPU space. So OTOY as a company is focused on content creation tools. Probably our best known piece of software is OctaneRender. It's a unbiased GPU path tracer. And we've actually been showing off each version at GTC over the last almost 10 years. And really, we've had about 2 years between every major release of Octane. Octane 4 came out in 2018. And these 2 years have really been about taking GPU rendering as a product through Octane through these different stages. When Octane first came out almost 10 years ago, over 10 years ago, really, with the beta, it was really focused on architecture, rendering, visualization. With Octane 2, we did add support for animations, motion blur, a lot of things that actually started to make GPU production rendering a reality and possible. And Octane 3 was a really big release for us. That's where we added volumetrics, OSL, and that's also where we started to see a lot of amazing work in the visual effects space being done with the GPU renderer finally. And that was a big step for us. It's kind of the dream that we always had with Octane. So I want to take a little bit of time to actually show some of the work that's been done actually in the past year by a lot of studios using OctaneRender. I think that was some truly beautiful stuff that we were seeing. Among those things that you saw were a lot of TV shows that are on the air now on HBO and Apple TV and Amazon. But we've actually had 2 Marvel movies use Octane. Ant-Man and the Wasp, main title sequence, 2 minutes, all done in OctaneRender and actually done on the cloud. This was in Cinema 4D, and more recently Captain Marvel, which we just saw in the sequence we just played. So it's kind of incredible to see, something. I mean, Octane really didn't start with production-ready features, but it got there, sort of mid-decade. And I think, we've really expanded that even further. And we're just seeing some amazing work being done by studios, and of course, many talented artists with that. And the ecosystem around Octane 3 also exploded. We have almost 26 different plugins in various forms. I think about 20 are actually out in users' hands. Almost every single 3D tool has an Octane plugin, and they have a lot of really interesting features. Among those are the ability to export an interchange format called OrbX, which we've actually open sourced with the immersive, with IDEA, which is an immersive media group. And you can actually import OrbX files into most of these 3D tools as well. So it serves as a really great scene interchange format. And as we looked really forward beyond that for Octane, we wanted to get this kind of quality that you just saw into real time. And so Octane 4 was about really pushing the boundaries with that and getting Octane to run even faster and interactively, even as a full production-ready path tracer. The way that Octane works is that you can actually run it in the IPR, in the interactive viewport, and get real-time feedback. So a big part of making that happen and democratizing Octane itself was working with Unity. And we did a partnership with Unity in 2016, and it really came to fruition around Octane 4 in 2018, where Octane is bundled for free. You can just load it inside of Unity. If you have a sample Octane scene or a scene inside of Unity that uses Octane, it'll just load. It's actually our one integration that is not a plugin. And the idea there was to give the many millions of Unity users a production-ready renderer that can run on their GPUs. That's the beauty of GPU rendering, is you don't need a giant CPU farm. A lot of the things that you saw were done on just a handful of GPUs, 1 or 2 machines for full productions. So getting Octane into Unity was a huge challenge for us and also a huge opportunity. And to this day, it's still there, and it's something that people are really exploring. It has the ability, of course, to bring in things, but we can also make Unity games just run as path-traced Octane viewports, which you're seeing here. With Octane 4, we added another piece of technology called Brigade, which was designed for real-time path tracing. While the shading still is a little bit noisy, it's able to keep up with the game mechanics and still do path tracing on any NVIDIA GPU, which is pretty amazing. Unity itself does allow you to import stuff from other tools. So this is an OrbX file being imported from 3 Studio Max. And that does make it a much more useful integration when you're using Unity really as sort of an assembler from different production pipelines. Now, last year, we actually had another big release, Unreal Engine, Octane for Unreal. That work actually had started years before, but it just came out in beta. And it works just like it does in Unity. You can import OrbX files. You can take your Unreal scenes, and it automatically converts them to Octane, which you see on the top, and you get path trace quality graphics in Unreal. And that's something that we are investing in. It's definitely something that has a long-term arc. There's a lot of content creation is moving towards game engines, and a lot of that is being done in real time inside of things like Unreal itself. The quality is very good, but offline quality is something else altogether. It's actually still a challenge if you're doing even ray-traced hardware on top of rasterization to get the kind of quality that people want and use out of Octane. And so, we are exploring all those things in tandem, but we do feel that inside of game engine, even game engines now that are getting so good that the quality is not good enough for broadcast, there is a value proposition for doing the kind of quality that Octane brings to the table. And so you can see even in Unreal, there's a lot we could do. There's also some really fascinating features that we've added in the Unreal integration. For example, you can overlay Octane with the Unreal viewport, and you get the ability, as you're seeing on the right here, to mix and match anything you want with the Octane output, which is great. You can also, in Unreal, import VDB files through Octane and render those. And we feel that with Unity and Unreal, we have a good sort of foothold into the game creation pipeline. And to provide the highest quality rendering in real time, and eventually AR and VR and holographic, is a huge goal for those endeavors. Which brings us back to where we are today in the last 2 years. We've built on all the things you've just seen. And as we look ahead into the next decade, a lot of what we've been doing, even getting path tracing to try to work in real time, is going to be more challenging as we get into technologies like holographic display panels, which are being built right now and have just massive resolutions, and they are going to require even more compute power. And we've also started to leverage AI in our rendering. Denoising is a huge part of Octane now. So I want to talk a little bit about, just in the last year, since last year's GTC, what we've been doing and what Octane's added into the mix. And there's been a lot. We've actually accelerated the release of Octane from once every 2 years to more like every 4 months. And Octane 2018 had a lot of great features. There was a lot of improvements in the AI denoiser, which you can see here. It works really well. It's something that we built ourselves. We're not using optics or the Intel denoiser. We just felt the best way to do this and to get really complex denoising that understands what the renderer is doing is to build it into Octane. And there's a lot of data that Octane generates to get this kind of quality. In order to denoise through glass, it has to understand the surfaces of the scene. So we could have built a simpler denoiser or used optics, but we felt the best approach for us was to invest in our own. And I think that the results of that speak for themselves. It's actually used in tons of productions. It works great. It doesn't need multiple frames. And you can see here it denoises in a fraction of a second on a recent NVIDIA GPU. It uses cuDNN, which pushes the GPU even more than what we could do through CUDA. And that's been a really promising way for people to speed up renders. You see here, these results are really just 1 second. Instead of rendering to 5,000 samples, you're done at 50, and it looks really good. And the more samples you give, it doesn't have to be a second, the better the denoiser works. So that was something that made a big difference when we introduced that in Octane. What you're seeing here is also another improvement that we made in the last year and a half or so, which is to improve the volumetric rendering in Octane to make it much faster. That's still a top feature request from a lot of our users. Can we get volumes to render even faster? And to that end, we've also made significant improvements in Octane 2019 with the volumetric denoiser. We have a specific denoiser just for volumes. And with better training and some other improvements, it got to be about 3 times better last year, which is great. And the other effort that we've been working on inside of Octane is to go beyond sort of triangles and volumes and to do things that are fully procedural. So we created something called Vectron, which is a procedural primitive. You can author it in open shader language, which is a part of Octane. You can see here, this is a fractal object that is completely generated at runtime on the GPU. And the other thing that we added last year is we added the ability for you to do shaders for displacement. And that works with shader vertices. You can also now take OSL shaders, you can send them into volumes, which again, the less that we have to bake into a data set like a volume, the better. And so OSL just operates entirely on the GPU. We've done a lot of work there. The other big improvement, I think, in the last year that we've done to Octane has been to add material layers. So material layers are really simple in the sense that you could just add different BRDFs like metal and other things, and just stack them on there like Photoshop layers. And in Octane 3, we had actually built OSL closures, which allow you to sort of create any kind of arbitrary material. But what we found, even with OSL for textures, which are simpler, is that a lot of our users and artists really just want things to be node-based and driven by that. So what we've done with material layers, and what we're still sort of working on, is to make it so that you can just use nodes to do everything you could do through OSL closures. And I think that work is still going to continue, and that doesn't mean that at some point we're not going to go back and revisit OSL closures. We just initially pull that feature back because the OSL closure system really pushed the CUDA compiler, and you'd see long compiling times when you'd change materials, and we wanted to keep that really fast and fluid. So things have improved somewhat in the last few years. We may go back to doing OSL closures, but for now, material layers are really what artists can use today to make all that happen with material stacking and really do complex effects there. And with the other thing that we added last year, we have OSL distortion maps and other things you can do inside of what we call the universal camera, which is a collection of OSL shaders that give you much finer grain control. And you can do distortion maps. You can take UV maps from distortion maps from Nuke and apply them in there. But it's given a lot of artists great flexibility and freedom to do really beautiful things. And that brings us to 2020 and this year's roadmap. So first, we have Octane 2020, which we put out in beta in November of 2019. And there's a lot of great features in Octane 2020. I guess the most prominent one, and the one that makes the biggest difference, I think, to many of our users, is RTX hardware acceleration. And we rebuilt that in Octane 2020 with Optics 7, which is an API that NVIDIA put out late last year. And the speed results in Optics and with RTX really speak for themselves. I mean, most scenes that see any sort of speed up, because things that are tri-mesh based are really what you need to get the Raytracing hardware and RTX to give you a speed up in Octane. A lot of users, their production scenes are getting 2 or 3 times faster. And that's fantastic. Even scenes that are really just mostly just shaders are getting about 18% speed up, but a lot of scenes are in this range. And then some scenes, which I'm showing here, like this one from Nest Graphics, are user reporting 15 times faster. And we looked at it, this is a real scene. The version of Octane that was been out for 8 years before we added RTX support does render it 15 times slower. And the reason why RTX is so much faster is because you have a ton of intersecting triangles. And the way that Octane works, it's an unbiased path tracer. There's a lot of things it needs to do, but ray tracing hardware in particular makes a huge boost. In a scene like this, it is an order of magnitude faster. And there are scenes out there that are in users' production pipelines that are actually getting the speed up. But typically, you're going to see a 1.5 to 2.5 speed up, and sometimes a lot more. And in some cases, you'll see nothing if it's just volumes and there's absolutely no triangle data in there. But that's something we're going to keep improving. Now, I want to talk about why we chose optics and why we moved to that. Last year, when we put out a preliminary version of Octane 2019 with RTX, we used Vulkan. And Vulkan ray tracing support is fantastic. It's very low level. And last year, it really was the best choice. Optic 6 didn't give us that opportunity. But what we found towards the end of last year, and which is why we made the change for Octane 2020, was that Vulkan and CUDA interop is complicated. It's experimental. It really hasn't been done before, especially with the kinds of things we're doing with mixing hardware ray tracing. There was a lot of duplicated memory. There were some issues that really were at the driver level that even NVIDIA was telling us basically were going to take a while to fix. So it was for that reason that we felt that Optic 7 was the better choice towards the end of last year. It was actually a fairly quick decision, and we integrated Optic 7 in really about 2 months, and it made it to 2020. And so all of our issues went away in terms of the Vulkan CUDA interop problems that we had. And so far, so good. I mean, everything in Octane 2020 with RTX really is stable. It runs great. It takes up a lot less memory. That doesn't mean we won't revisit Vulkan RTX down the line for Octane, but it probably won't be this year. We would need to essentially rewrite all of Octane for Vulkan to get rid of the CUDA Vulkan interop issues. And we just think that Vulkan is still a little bit early. Maybe in a year, that will make a lot more sense. So Octane 2021 also has a ton of great features, not just RTX speedups. One of those, which you're seeing here, is that we've licensed the Cinema 4D noises from Maxon, and we rebuilt them in OSL. And they can be used now for procedural textures and effects inside of Octane for Cinema 4D, and it looks and works great. A lot of users really were asking for that. We also have volume displacement in Octane 2020, so you can feed the Maxon noises to that. And we've also taken Vectron to a whole other level. We've added something called Vectron volumes, which means you can take these totally procedural fractals and OSL shaders for surfaces and apply them to volumetric objects. And this is super interesting because what I was showing earlier, when we just had a VDB file with a shader on it, well, you can't really create a new VDB. You still have to just apply a shader to that volume. Whereas with Vectron, you can just totally create a volume procedurally in the node graph whole cloth. And that's really powerful stuff. You can see here where we can apply any sort of Vectron effect. We showed this last year. It was from the shader toy examples. Very easy to take shader toy GLSL code, by the way, and use it in Vectron nodes. And we've also made it so that you can do operations. What you're seeing here is I'm taking two Vectron volumes and I'm actually combining them together in the node graph. You can see here the non-volumetric version is essentially a metaball. And the way the Vectron works, it's so great. It really is calculating all these surfaces on the GPU. There's no need for the host app to do anything. You don't need to go into Houdini and build all this. It's just a very simple shader node. The other major feature in 2020 is random walk. We spent a lot of time on this. It makes skin and subsurface scattering so much better. And you see here the results look absolutely awesome on skin. This is random walk in our Blender integration running live. And it's just very fast, and it gives you beautiful subsurface scattering almost instantly. And it's something that is a little bit challenging to put on the GPU, but it works fantastic in Octane. And it is spectral. All of Octane is spectral, which does give you higher quality when you're dealing with materials that bend light in different spectrums. And certainly when you're doing any kind of design work that is related to jewelry or metals, that's really important. It's also important for things like hair as well. We've added a hair material, as you can see here in Octane 2020. Works great. It's a whole new BRDF model. And it makes hair in Octane much simpler for artists to use. You can see the controls here are straightforward. It's based on the Disney BRDF model, adapted Octane spectral rendering. And that, along with random walk, give you a lot of great features for skin and hair rendering. I talked a little bit about volume displacement. That's a new feature in Octane 2020 as well. That allows you to take any volume, a VDB volume, for example, and hook up a noise shader to it, an OSL shader, and displace it. And the results are awesome and very fast and instantaneous. The other improvement in 2020 was a revamp of the DIRT system. Essentially, this is an ambient occlusion kernel. It allows you to shoot rays. Inside of OSL, there is a trace function. We felt that was something that we didn't want to add yet in Octane because it can be abused and it can slow things down. So the things that you would want to do with a trace function are things like DIRT. And adding more and more capabilities into the DIRT shader made a lot of sense. It does a ton right now. And if users want more, we'll probably add it, but I think for now it does a lot, and it works great. The other major feature is Spectron. And Spectron was something we added in Octane 2018 and 2019 to handle specific light types. It's procedural, so you can create your own out of primitive types. But really, 2 primitive types were missing until Octane 2020, and they're in there now. Up until now, Octane has really just used mesh emitters for everything to keep things completely physically correct and keep them at the highest quality. But if you're looking at other renders, typically they have light primitives. In fact, they only recommend that you render with light primitives because mesh rendering is really slow. Now, it's not slow in Octane, but it is. I will say that when we added these quantum point Spectron lights, yes, it is faster because we can sample those faster. And the great thing is the quality doesn't go down at all. So if you're using these quad and sphere lights, we're going to add more down the line shortly, you're just going to get much higher quality rendering for the same number of samples. So it's, for the same number of samples, you're getting 4 times, equivalency for direct lighting. And it's great. So we've seen faster renders in Octane 2020 with these light primitives. Makes a big difference. And you can also take, in the distribution function for these light primitives, you can just take a simple shader, which we're shipping with Octane, that allows you to do very nice spread functions, all procedurally. And that's actually shipping in the 2020 final version, which should be out middle of April. So if you're watching this video, you're probably already able to get the 2020 final version. See here, the spread function's actually got a lot of controls in there, and you can also use that to add a gobo. And these gobo lights for OSL shaders and Spectron they're very fast. And again, because OSL is a very powerful system, a lot of users want these things baked into these top-level nodes. So we're shipping these OSL shaders inside of the node system in Octane, so everyone can use them in Octane 2020. The other big improvement, again, a lot of these things are things we wanted to add earlier. Big improvement here is we have primitive attributes for everything now. Hair and points. We added in 2018 the ability to do that for triangles. But this is important for Houdini and even C40. But a lot of things in Houdini were missing in Octane because we didn't have the support in there. And again, every time that we add something to a GPU render, it does slow things down. So it's like a game of Jenga. Adding these pieces without slowing down the render is really why sometimes we waited a while to get those in there. And we're pretty excited that the Octane 2020 is actually faster than any version of Octane we've had before, and yet it has all these new features. And it's kind of a challenge with GPU renders. You're not dealing with the same universe as CPU rendering. There's a lot of reasons why it's been challenging. We've had to rethink things from the ground up to get GPU rendering to work. Here in this slide here, we're showing that we added a separate shadow step length for volumes. Volumetric rendering is something that is absolutely beautiful in Octane, but we're working on features that can make it even faster, give you more control as artists. Universal camera got a lot of improvements. One of them was a split focus diopter, which you're seeing here, allows you to change focus plane. Again, we're sort of writing all of these shaders in OSL, but artists want to be able to have them, so we're baking that into the universal camera. And there's a lot of great features that were added: optical vignetting. You can have aperture textures, aberration distortion. We're working on really exposing the ability to do a lot of these things where we can through textures and shader nodes that you can add in, and that works in progress. We also added a sky model in Octane 2020. The new one's on the right. Looks great. We added rounded edges last year in Octane, but this year we've actually added a few more controls to improve it. You have control over the number of samples, which is helpful for artists to control the quality. And we also took all of the OSL shaders out there that people collected. A lot of them are actually from the Autodesk repository that ships with 3D Studio Max. And we put them on LiveDB, so all the artists and all the tools can download them and use them. And we also took a bunch of utility nodes that were very popular on the forums. We cleaned them up and we put them on LiveDB as well. So users can access all of these in any version of Octane after 2018. And we've completed this work with a whole bunch for Octane 2020. We also, in Octane 2020, added support for ASUS, and we're now looking at supporting the new version of ASUS as well. ASUS is new. It's not necessarily completely supported in all of the DCC tools that Octane runs in, but it's internally supported in the engine. And you can export ASUS EXRs today, and we're going to be working on more features, especially as DCC tools like Cinema4D add more and more support for these kinds of pipelines. OpenColor.io is another target for us as well. And lastly, we've also been working on a special build of Octane that is running inside of Pixar's Hydra. So what you're seeing here is a Hydra render delegate version of Octane running in Houdini 18 Solaris, which allows you to take any render delegate, including RenderMan and Arnold and Redshift and others, Octane as well, and just drop it in there into the Solaris viewport. And so here we are rendering scenes through Hydra. Now, unfortunately, right now, a lot of scenes in USD are using the USD preview surface. But inside of Houdini, you can also feed the Solaris viewport Octane materials that are created in Houdini as well. And we're also looking at supporting other things in USD, and we'll talk about that in a little bit. So Octane 2020 is out and stable, and it's a great release. So we look forward to users doing even more amazing work with it this year. The other major product that we've been working on for years, if you look back at some of those earlier slides I was showing from previous GTCs, we've been working on cloud rendering forever. It's something that, that keynote slide from 2013, we were showing our first version of Octane Cloud. Render is the ultimate solution. It's truly an amazing product, and we're very excited to launch that as well mid-April. Render takes everything we've done with cloud rendering in the past and turns it on its head, because we've been limited in a lot of respects on the public cloud by a limited number of GPUs. And while Octane is very fast, if you have 10,000 frames to render and there's only a few thousand GPUs in the public cloud, that's a problem, especially with the number of users that we have. So what we did with Render was we decided to create a cryptocurrency, a render token, that allows you to essentially fulfill on your machine a job that's normally handled, let's say, on Amazon through our previous cloud service called Orc. And we did this in 3 phases. Now, there's tons of GPUs out there. There's hundreds of millions of GPUs. There's only thousands on the public cloud. So what we did with Render was we created an Ethereum token. It's pegged to essentially whatever 25 cents of that same value you can do on the public cloud, which is largely the same between Amazon, Google, and Microsoft, and so forth. And Octane Bench is our benchmark in Octane. It's been around forever. It's used, frankly, by a lot of people in the industry, even by a lot of third-party render farms to advertise how much render power they offer. So we pegged the amount of Octane Bench work on Amazon to the token price. And we sell credits, basically, that can do this now for Orc. And now the token allows this to happen on a distributed system of thousands of GPUs. There's about 16,000 GPUs that came on during the sign-up. And there's a very simple system application that you can install locally to run these jobs. And the way the render interface works is web-based. This is the beta, which is wrapping up. And it's awesome. If you've ever used Octane Cloud Work, which is always run on centralized nodes, Render is a much better version of that. This is the workflow where a user can go to a web page, check on how fast the renders are being processed. All these renders are being done on some random node out there. We've had a lot of people sign up, but typically anybody, with the full network being public, can add their GPU power to the system and, get a token that they can actually cash in when the work is done. So this is beautiful. I'll let this play. Done by Andrew Lebrock on Render. We're in the beta. Gorgeous. So every single frame was done during the beta. You can see here how many render tokens it took. It was rendered in 4K, full path tracing. 2020 render is not a lot. It's really cheap. And now I want to talk about, that was during the beta. I want to talk about a very exciting development during the beta. We did get our first commercial customer. And now we've had a ton of commercial customers on Orc, our centralized rendering service that was been running on Amazon. But this was the first commercial job that was ever done on the decentralized network that is that powers Render. And so this project that I'm about to talk about was done. It was a last minute request that came in from an Octane user, and the Octane user that did this job is John Knoll, who's a legend. And it really came out of the blue. I was so excited to find out that, one, John Knoll is an Octane for Moto user, and two, he came to us with a request. This is for the Hayden Planetarium. He was rendering 4K and 8K renders in Octane for the dome there, and there was a really tight deadline. And so he came to us, and we offered Render to help him finish for a deadline. Yeah, I think it was in a day or so, and Render performed beautifully. We got a great testimonial from it. It's really one of my favorite case studies. And unbelievably, as we were, letting people on Render earlier this year during the beta, this actually, John Knoll just turned out to be our first real commercial customer. And so I feel that's a very lucky and auspicious start to the commercial work that we're going to be seeing on Render. But the important piece here is that this really is an example of a commercial project being done not on GPUs on a render farm or on the public cloud, but on distributed GPUs. It could be your GPU, and we do have security in Render. It is end-to-end encrypted. It's as secure as it can get. I think it's probably more secure than a lot of third-party render farms out there that don't have great virtualization or protections. But nothing's completely secure, but it's good enough for tons of commercial projects. And having John sort of kick us off for commercial work on the decentralized part of Render was fantastic. And we also have some other really incredible news to share. Obviously, Render so far has been built around Octane. It's actually designed around Octane Bench, but that doesn't mean that's the only type of job that we want to run on the service or the only render. And we've been working to bring in other partners onto the service, and we have something super exciting to share today, which is that we are bringing Autodesk Arnold onto Render. We love Arnold, and Autodesk as well. We've been working with the folks at Autodesk for a decade, and we know the Arnold team really well. And we proposed bringing Arnold onto Render not 2 years ago when we actually started developing the service. And the results really were, the feedback from the team on the Arnold side was great. And we do want to create something bigger than just Octane with all the work we're doing. I mean, Render is a much larger initiative than just one render, one product. It's truly meant to be an ecosystem, a platform that we can all leverage to get us the amazing kinds of capacity and other things that are just difficult. And in some ways, we don't want to just keep that for Octane. So bringing on Arnold is fantastic. And there's some really wonderful collaborative elements that come from our work with Autodesk on this. So one of the big pieces is we want to standardize the way that renderers on Render can leverage their machines. There's a lot of work that's going to be done on our part to get Arnold to run on Render. We have to get Arnold procedurals, which are essentially compiled libraries that can run essentially from a render stream in memory. But what we really want in the long term is we want to find a way to standardize a scene that can be launched from any DCC application we support. Remember, there's over 20 of them. And we want that to work in multiple renders. So we need a standard for that. And while we've open sourced everything that's gone into Octane Scene Graph through Orbex, there is something that we felt was valuable in what Arnold's created with Standard Surface, which is now the standard surface inside of Arnold. We are adopting that in Octane. It'll be built in to Octane Brigade, and it'll become essentially the standard through which we can have multiple renders work with the same sort of materials being sent from a render job or a GTC tool. The other thing behind the scenes that we're doing is we are using the Hydra render delegate system to essentially bolt in arbitrary renders. Now, right now, it's just Arnold and Octane. We're also building another render called Brigade, which we'll be showing. And all three renderers will have the ability to take anything that can be sent through Hydra and output hopefully the same results. And so that's why we're building in Standard Surface into Octane. We're also going to be taking all the optimizations that come with Standard Surface. It has fixed BRDFs, things that are a little bit different than the universal material, which will still be in Octane. But we'll have the ability to flatten anything in any DCC tool to standard material. And inside of Octane, we're going to have very fast rendering for the Standard Surface. And it'll look exactly as it does in Arnold. So a lot of this work is really to bring commonality so that you just have identical assets that could be shared between us and Arnold and hopefully other renders, especially those that want to come on board Render and leverage an API that is essentially open and based around standards like Hydra, USD, and now Standard Surface, MaterialX, and others. So there's a lot more to discuss to even unpack with all the amazing things that we're going to see in Render, having now multiple renders on the service, but also just in general for the industry, collaborating between, just our two renderers is towards open standards is really valuable. We want to see things like what we built with Vectron become standardized in open shader language. Arnold has implicit OSL surfaces that are very similar to that. And so by documenting and coming up with something, even if we submit that to IDEA or some open source group, collecting everything you need so that we truly get to an ecosystem where scenes, materials, shaders, everything just works the same between renders, that would be fantastic. That's one of the big wins, I think, from collaborations like this. So next up on Render is our public launch, which is in April. So depending on when you're seeing this, it may already be launched. It's coming out of beta after 2 years. It's so exciting to see that happen. And even during the beta, obviously, we're doing commercial projects like what we did for John Knoll. But this launch means it's going to be open to everyone. There's been a private beta. It's been sort of closed. Now, every Octane user or OTOY user, since we're going to have more than just Octane eventually on the service, is going to be able to just go and use this from any of the tools that Octane supports. So with us coming out of beta, we're also introducing essentially multiple tiers. There's actually only been one tier in Render, which has been the decentralized nodes. And we're adding a new enterprise tier, which does loop in nodes still running on Render, but it's on the public cloud, so they are more secure. And with that, we can actually deprecate our previous service org. And we've also added something else, which are Render credits. So Render credits were created because during the beta, we saw, and we got a lot of feedback that a lot of artists are just not experts on cryptocurrencies. They don't know how to set up wallets, or if they do, it's a whole thing. And we don't want the kind of friction. I mean, a lot of artists just wanted to go to our shop page and just buy credits. So, and use the Render network that way. So that's what we added. Render credits basically are that. It allows you to go to the same web page where you've previously bought credits for Orc, or you've purchased Octane or subscribed to Octane, and you can just get Render credits. And it's really simple. You can also, of course, still use on the decentralized nodes the tokens that are available from the Ethereum network. But the credits are identical. I mean, one credit that you buy for fiat on our shop page does the exact same amount of work on the Render network that one Render token does. It's the same exact Octane bench hour per cost. And you can use these credits on all tiers, enterprise as well as the decentralized tiers. Now, with these new tiers, there are a couple of differences between public and enterprise. Enterprise tier is basically studio certified. It's called TPN, MPA certification. So Ant-Man and the Wasp that was done on the cloud, that was on TPN certified providers. That is typically the big public cloud guys. But we want those nodes on Render. They're in a special category. You have to upload your artwork to a Render enterprise page is different than the normal one, and that's to ensure that everything is done under the maximum security. But on the public tier, you do have a couple of things that are different from both Orc and the enterprise tier. For one, because anybody can add their node to the network, we have no idea necessarily who that is. There is a watermark that's generated on those renders, and there's an escrow system for tokens to be exchanged. We also had the ability to do essentially what we wanted to do on Orc on the public cloud for years, which is to be able to leverage things like spot instant pricing and other things, but there's never enough capacity. That's a big thing is with capacity now on Render the way it is, we could do something where if you want to have a cheaper render and you don't need it as quickly, it could be a tenth the cost. There's no reason for us not to offer that. As long as the render pays out more than what the electricity cost is, I think users on the Render network that are in the decentralized tier will want to support that. And the other thing, of course, that the public tier does, because it's fully decentralized and consumes tokens behind the scenes, even if you're paying with credits, is you can also just open in your browser MetaMask, which is a cryptocurrency wallet system, and you could just use that to pay for your Render jobs and not go through us and not buy credits from us, but actually go on an exchange that has Render and use actual Ethereum tokens to pay for these jobs, which is how it's been up until the public launch. On the enterprise tier, we have other things besides security. Because a lot of the enterprise nodes are running on the public cloud, those nodes typically can do crazy things that the average node on Render and the decentralized network doesn't do. It can have 8 V100s, 500 gigs of memory, 8-way NVLink. So, if your job needs that, the enterprise tier is where you need to go. Now, the enterprise tier, along with Orc, does have some limits. There's not a ton of these nodes out there. But one thing that we're doing is we're bringing on more partners. Orc really was just us and Amazon and AWS. But today we've actually been able to bring on multiple partners for Render Enterprise. We have an exciting partnership with Microsoft. We're working with Google, and Azure is going to be supporting Render Enterprise. And that's fantastic. You'll see some partnership announcement with Microsoft this month. Not just, by the way, for Render on Azure, but also Microsoft is helping us with getting Render to run on Windows. You know, driver support, things we need to do to get jobs to run securely and quickly, and that's a big deal for us. So getting Microsoft onboard Render is fantastic. We're super excited, and that's what it takes us. I mean, phase 1 through 3 were really everything we needed to get to this point. You know, getting you know, high latency render jobs, cloud jobs being done, and launching that and building everything around that, the ecosystem, the tokens, the payment page, everything. So the next phase is phase 4, and phase 4 is really all about using the benefits of having a blockchain to do way more with Render, and that means you can assign IP rights to the things you have. We also want to focus on real time, and there's also a development kit that we're making to build services and software. We're using that. It's called the Render SDK. We're using that behind the scenes to onboard other renders. We're using it ourselves to rebuild Octane. It's pretty cool. So Render SDK. It is a fully portable compute library. We use that ourselves now for Octane, but we want to allow others to build software and services with that. So we are this year launching OctaneX, which I'll talk about in a little bit. It's built entirely on the Render SDK. And what we want to see with Render and the Render SDK is, you know, for developers to build things on there. I mean, we've obviously built Octane, and we can use the Render SDK to load in existing pieces and modules for certain platforms. But the idea is that if you use the tools and the programming front end, we can let you publish software services that plug into all those DCC tools we showed earlier. So, for example, Arnold running on Render for high latency jobs. Well, we can also run that inside of all those DCC tools you saw as well in the IPR. And that's the power of Render. It just gives you the ability to publish a piece of software and bring that across multiple different software and applications. We've done a lot of the work to sort of hook Render up to those DCC tools. And Octane is not the only beneficiary of that. Anything that you create with the Render SDK goes towards that. The front end is all GLSL for compute. GLSL compute is what we found to be super portable. You have C++ for CPU code, and we're actually adding inside of Octane the ability for you to just write C++ and GLSL code, just like we do now for Lua, for script nodes, and for OSL. And we have a binary linking system, so you don't have to ship C++ or GLSL code if you want to ship it as a compiled product like we do for Octane. That works through the Render SDK and the publishing system. And as I was sort of alluding to, really sort of beyond you know, the pieces we have now for Octane, what we are most excited about is for example, letting you build a Hydra render delegate, which is Pixar's, you know, Hydra has an API called render delegates that allow you to plug your render and have it work in all Hydra applications. The problem is Hydra isn't everywhere. So we do have, in Octane, what we're building is Hydra support inside of every single current Octane plugin. And that means that any Hydra render delegate could run inside of any of these tools. And that also means that if you're developing your Hydra render delegate in our API, you can cross-compile that and have it run on Metal, on iPhones, everything. There's also other work that we want to do around in the scene graph. Hydra also has a scene graph API called Hydra Scene Delegate, things like physics and other pieces. We want modules and plugins that go across different tools to support that. And Render has so many backends now. I mean, we run, of course, on CUDA, CPU, but Vulkan, Direct3D, and Metal are really interesting. And Metal in particular is now a necessity for us because there's no CUDA support on Mac or iOS. And Octane has been CUDA for 10 years. So we used our own GPU tool with the Render SDK to build Octane. And 10 years now of Octane releases on CUDA, we're about to put out OctaneX, which we announced last year. It is Octane 10. It's the 10th version. It's the 10th anniversary. It's really a truly amazing product. It's designed with something really critical in mind, which is to get Octane to places that it could never go before. CUDA notwithstanding, we couldn't run Octane on an iPhone or an Intel chip. And you know, that's something that changes now with the Render SDK because we can target through Metal, you know, Intel integrated chips on laptops, on MacBooks. We can also target phones. And to get this to work and to validate whether or not this SDK and this backend actually is functional, we had to take all of Octane's CUDA code, 10 years worth of code, and rewrite it from scratch over the last 2 years, which we've done, into GLSL. And we can also use Metal shading language to optimize any GLSL, which we've done for OctaneX. And the Metal version is now done. It has full pixel parity with the latest Octane 2020 release coming out this summer. and it's awesome. So you can use this for many things on the Mac. Last year we did tease one of those, which was headless rendering. So headless rendering, what you're seeing here, is only the minimum amount of Octane running on Metal is on this MacBook Pro. It's actually connecting over the network, over LAN here, to an NVIDIA GPU, which could have RTX, anything you want. All of that rendering is being done over a network render slave, and OctaneX allows that to happen. We've also added support, not just to do that over LAN, but to do it over cellular. So this is actually, I think what you're seeing here is a 5G connection over a cellular hotspot, running Octane on my MacBook to a GPU that's essentially in a whole other office or place. It could be on the cloud as well, and it's just using the Intel GPU locally to do tone mapping. So getting headless and network rendering to run over 5G, 4G is something that we're excited about. Headless rendering also makes that easier. But with OctaneX, we have something else we do. We can actually run all of Octane now without headless rendering, without connecting to an NVIDIA GPU, all on the Intel GPU itself. What you're seeing here is, in fact, that working. And that's brand new. So we didn't have that last year. We have that this year. Everything works. Path Tracer, kernel, all of Octane's features now run on Intel GPUs. I mean, they're not obviously nearly as fast as on an NVIDIA desktop GPU, but it's about as good as, this is a 13-inch MacBook. Is about as good as the last time I had a CUDA device on a 2013 MacBook Pro. That was my last CUDA MacBook laptop. So we're giving usable performance to millions of these MacBooks now. What's even more exciting is OctaneX running on iPhone, and we've actually been able to build a full version of OctaneX that runs on the A13 chip, the one that ships in the most recent iPhone 11. And we've been working on this for years. The last couple of years, we've been showing pieces of Octane. We've had a path tracing kernel, which you're seeing here, which runs really nicely, but it's not been the full Octane. I mean, Octane's just an enormous piece of code, and it's taken us years to get to the point where we now have all of Octane, not just what you're seeing here, everything running even on the iPhone. And I'm going to show you how that works. So along with getting the actual renderer done, we've brought over pretty much all of Octane standalone as well. It's a little bit of a challenge, on the iPhone. This is all still experimental. It's just a work in progress. But on the iPhone you're seeing here, running Octane standalone, fully ported, everything, not just the GPU code, but the Octane code itself has been ported over to ARM64. We can run in both something that can be used for touch on the phone. This is obviously a shrunk down version of the interface. It's pretty scaled down, but we have a high DPI version. If you want to use AirPlay or plug in your phone to a full resolution display, you have a full resolution version of Octane that runs, which is really cool. And to test it and to run it, just like you can with the desktop version of Octane standalone, you can load in URBEX files. So you can load in your URBEX files from, you can sync them from your Mac, from iCloud. You can also load them from the Files app, which I'm about to show you here. Look at that. When you load an URBEX file, it just loads and renders. You're actually seeing that render of the box scene from the Octane bench scene running on the iPhone. It's absolutely incredible. And we got this working. It was just amazing. This is actually the first time we've actually shown direct lighting or path tracing kernels, full Octane really running on an iPhone device. It really works. You're seeing identical results on, look at that, this is an A13 chip. It says that in the bottom right corner. Speed's actually about as good as, my first Octane GPU on the desktop. So, 8 or 9 years ago. I mean, the iPhone has probably about the same speed as the Intel chip. I mean, maybe there are things we're missing and that might change, but so far our testing is showing that it's pretty close to the Intel Iris chip in the 13-inch MacBook on an iPhone 11. And you can finish renders. I mean, that's just 3 minutes to finish that render. Many of you probably have played with, if you're an Octane user, played with this benchmark scene. We, of course, after getting these early scenes loaded, we tried everything. We started to load in all the scenes we could, and there's path tracing from the idea scene. This is from the Octane sample scenes. It looks just absolutely identical. I'm about to show you something even cooler than just path tracing. This is the PMC kernel running on the iPhone. It's full caustics, volumetric caustics. Is probably a really tough thing to run on any device out there, but it's actually rendering on an iPhone 11. And so these are all sort of simpler scenes. We took another PMC scene with subsurface scattering random walk. You're seeing it here running on iPhone 11. I took a screenshot of the actual phone here, so you can see what it looks like on the device. And you've got subsurface scattering random walk SSS on the character on the right. You've got complex light transport. That's why we use PMC for this, and it is just identical to the output on the CUDA device. So it's really fascinating to sort of see, that happen. And, from the 1080 on my laptop here, I mean, essentially for PMC, the phone is running maybe a sixth the speed or something like that. It's not that bad. It's pretty good. So you're talking about 20-something octane bench for the phone. If that pans out, that's pretty good. And that's in everyone's pocket. These are still early numbers for speed. But the other thing I want to show here is you can actually finish a render on an iPhone. I mean, this is a 28-minute render, but that does make your phone the ability, give you the ability to finish a full final frame render and deliver it. We've actually had to work on thermals to get rendering on an iPhone to work and not overheat. That's actually also a requirement for eventually putting this out on the App Store. OSL completely works on the iPhone version as well. You can use an editor that runs on the iPhone here to write shaders. OSL shaders just work. OSL compiling works on the iPhone. You can see it here with a Mandelbrot shader. It's super, super cool. And that means really there's nothing missing on the iPhone. That also is, of course, an important validator for just Metal in general and the Render SDK. You can also kick off jobs to the cloud on Render from your phone because obviously you have even less power on a local device. Of course, you can also connect to a high-end NVIDIA GPU that's running CUDA or RTX or any of those things. But if you just were to plug the iPhone into a MacBook, you would, because you can essentially turn your iPhone Octane app into a render sleeve. You can double the amount of rendering that you can do between the two. It's remarkable. So now I want to sort of focus beyond what we've been doing in these releases and beyond the porting work with the Render SDK. I want to go back to Octane and talk about our feature roadmap. We've done a ton of features as we've just gone through in the last 2 years, 1 year. 12 months in particular, it's been pretty stellar. And I think we're actually pretty good on features, but there's a ton of new things we're working on. So we'll get into those in a little bit. A lot of our feature work is at this point guided, because we've done so much, I think, at this point. We want to know what users want, what users tell us is missing, and that's a big part of what we've been adding to Octane and are adding to Octane in the coming months. So 2020.2, 2020.1 is at this point stable. 2020.2, the ETA is this summer. And the focus of this release is mostly performance and stability. And, it's not going to be a very, long roadmap to this thing. It's just a few months, but we want to focus on a number of things that are, that we could do in that regard. I mean, I think we have so many features that's crammed in last year that, focusing on stability and on performance make a lot of sense in the next couple of months. But we have another priority as well, which is we've added amazing RTX support in Octane 2020, but we're doing a major overhaul in 2020.2. And the goal here is that you never need to go back to RTX off. Now, there are versions of Octane 2020.1 where we've shipped it with RTX on during the beta. And I had people essentially, we have a flag that allows you to turn on and off because there's still cases where you go out of core or certain things are just not very fast. But we're not going to necessarily in 2020.2 ever need to even have that flag. It'll always be RTX on. And the reason for that is we are going to add things like out of core that'll work with RTX on. And it'll be faster than out of core as we currently have it in Octane today using CUDA, which means that you really don't need to have RTX off ever. Currently in Octane 2020, if you go out of core, it goes back to the RTX off wall back automatically. We won't need to do that anymore. We're also adding optimizations for things that are not triangle meshes. There'll be much faster rendering for splines, curves, dirt, shaders, rounded edges as well. And also another improvement that's coming in 2020.2 is lower memory for RTX. In general, we also want to work on lower memory in the non-RTX parts of the render as well. For stability, a lot of things, in the GPU world are tricky. Drivers can cause problems that, just don't exist in the CPU world. So there are things that we want to do to sort of mitigate issues where Octane goes down and needs to restart, or the GPUs pull down the process. So one of those is making Octane multi-process, a little bit like how browser tabs have worked in Chrome. If Octane crashes, it will not cause the host app to crash. That's something that we're adding in 2020.2. We're also adding automated GPU reporting to really get to the bottom of when things crash. It's not like with CPU code where you see a lot of great debugging stuff. I mean, we want to get logs sort of automatically reported to us, look at drivers, things like that. And we're also adding something, what we've seen from a stability perspective is, we're using cuDNN for the AI denoiser. That pushes the thermal envelopes on GPUs really, really, really far, to the point sometimes, there are things in cuDNN we can't write in CUDA. It actually is higher performance, and I think the GPUs get really pushed to the limits. So in cases where that happens, we want to provide a fallback for the AI denoiser that runs on AVX2, which is essentially SIMD instructions on Intel and AMD chips. So that's coming in 2020.2. You'll have that as an option. You can use that for denoising. In certain cases, that will free up the thermals on the GPU. I think that frankly on more recent GPUs, that's not so much of an issue, but on older ones, it can be. And we're going to be optimizing and essentially rebuilding AIC in and out of core to be more performant and do even more than it can now. Out of core was introduced in 2018. This is essentially sort of a revamp of that. We're going to be doing a lot of speed ups as well for that. And we also we have NVLink support, which allows you to pull memory together. It works great, but we want to do even further speed improvements there as well. I mean, it's a pretty new piece of technology, and it's something that was really added on in 2018. So we want to again take another look at that and improve that in the 2020.2 release. There are other small things we're going to do to improve things like in memory. We're going to convert single channel RGB images to grayscale automatically. That's something artists have requested that can really help reduce memory and make it easier on artists. Small things for volumetric rendering in 2020.2, we can ignore volumes in the focus picker. And we also going to make the random walk medium rendered it'll be non-transparent if it's rendered inside of volumes. And right now, visible lights and volumes are an issue. We're fixing that. And render as well is going to get some improvements. Render itself is built into and shipping with Octane 2020, but in 2020.2, we're going to add support for delta syncing, so you don't have to upload a whole new OrbX file. It'll just work from the DCC tool and only upload parts of the scene, which is a really nice improvement. We're also going to export OrbX from C40 so that it just doesn't take about this, it's the same size. We're going to explore also licensing Cineware, which might allow us to put C40 files in OrbX packages. But the idea is to put more procedurals in there and make the export process smarter, which will help reduce the size and complexity of uploading to the render network. So beyond this release of Octane 2020.2, there's a lot of great things in the pipeline, and I want to show and talk about these pieces as they are coming together for this year. So I talked a little bit about modules built on Render, and Octane is just one module. We have two others that we're building that I'll be talking about in a little bit. Brigade, which is a whole other render than Octane. It's designed for real-time rendering. It'll also work through the Hydro Render delegate system that we're building and using for Octane and Arnold. And Sculptron, which is in alpha right now, which I'll also do an overview in a little bit. And these tools are really the first tools that we're building on top of the Render SDK other than Octane, and they plug in nicely to Octane as well. But that's something we want to expand for third parties. And we have our very first third-party tool that we're bringing into the Render module system that'll work across Octane and Brigade and Sculptron and any other DCC tool that runs with the Render API. And our partner in this is DjangoFX. We are joining forces. We're doing something truly special and bringing an amazing product called Embergen. We're building a new version of Embergen called Embergen FX. As you can see here, it is a real-time simulation system. It's awesome. What you're seeing here is the standalone version of Embergen, which will be available to all Octane users this summer as a subscription. Part of your subscription, there'll be a free version as well. You currently can use the standalone version of Embergen to create files that can be then loaded and imported into Octane. But the ultimate goal with Render and us taking the source code of Embergen, here you see the VDB now running inside of Octane, is so we can port that. We can actually get Embergen FX, the new build that we're doing, to run on things like Mac, which currently Embergen doesn't run on, iPhones, iPads, and also get it to become a module inside of the core of Octane, so that the Embergen nodes will just run and be exposed as core Octane nodes will. And this is something that other third parties can use as well. But with Embergen, we just felt there's such an amazing value proposition here. We wanted to really make that one of our core modules, and working with the amazing team at the source code level, for Embergen FX is really exciting, and it's a beautiful product. I mean, if you look at everything you're seeing here, this is all real time. And when you see Brigade, which we'll be showing in a little bit, those effects that you're seeing, which are here being rendered in OpenGL. Compute will be running with full path tracing in real time, and of course, we want to bring the same into Octane. And there's a lot that Embergen Effects can do. I mean, you can see here how interactive it is. I mean, I think just like Octane is interactive for rendering, Embergen Effects is going to give you interactive volumetric and simulation tools that are just amazing and very powerful. And this is still a very young product. I mean, the beta is just about to hit the summer. That's why we're waiting until the summer to release it to users. But these products are all going to work together great. If you're using Cinema 4D and you wanted Embergen, you're an Octane user and you've used the alpha version, you're in luck, because now all these tools are going to work together and will be available to all subscribers of Octane. And also we're going to make some versions of these available, as we have for Sculptron, for free. So in Octane itself, beyond these great modules, which we'll go into more detail beyond Embergen Effects and others, we do have a lot of features in the core render that are coming online this year. And I'm showing here some screenshots of the various different places where we've had user polling. And really at this point, given the maturity of Octane 10 years in, we want to focus on things that users, the majority of users really want. And it's basically been an interesting task prioritizing that and putting all these things together as we go through all these different pieces. But here are some of the features that we are going to be bringing post-Octane 2020.2 as quickly as possible into this year's release cycle. So one of those is much faster implementations of nested dielectrics in the public version of Octane. We've had work on this done before, but again, like everything else, we don't want to slow Octane down. So we've got a solution to get very fast nested dielectrics. This scene here by Raphael Rao that I'm showing here, it currently takes a lot of work to set this up in Octane when you have the boundary between different mediums. Nested dielectrics built into Octane 2020 is going to make this work really well. No speed hit, which is great. We're also adding full curvature nodes and shaders. So this is a curvature map that you're seeing play here, which was really nice. And then also there's a lot of work that currently you can kind of do in OSL, but we're making these built-in shader nodes. Even the utility nodes that were on LiveDB, we're going to be building these things in. And one of the things we want to support also in the release, which we're showing here, is the ability to take a shader or a texture and feed that into the UV coordinates of another texture. And that's what you're seeing in this example here. The other thing that we're working on, and they're pretty far along, is seamless texture tiling. It's also called chaos texture mapping. You can just take an input texture and just create seamless infinite textures and tiling. It looks beautiful. It's very fast, all shader based. It works great, really easy to use. And given now that you can use textures for displacement and many other things, it's really nice. Improvements to the gradient system are going to be coming up pretty quickly as well. We're going to have a gradient generator node. The gradient texture node will have static input pins, which is helpful. And then a lot of the utility shaders that we've made available on the forums and in LiveDB, we're baking into Octane, and we're going to do everything we can to improve them. Some of them are actually from users, like the ray switch node that you're seeing on the bottom right here. But we're also going to add full math, logic, and state nodes. Pretty much all the utility nodes that you see in Arnold, by virtue of us also adopting standard surface and having scene parity with Arnold, will be in the native utility shader system pretty soon, which is great. Things like RGB splitters, all that stuff. I mean, that'll be probably one of the very first updates, either in 2020.2 or right after. We're also adding bitmap support. A lot of users have been asking us for palette exclusion mapping. There are OSL shaders out there that can do that, but we're going to make that a built-in feature. Rounded edges textures are going to be coming up pretty soon as well. And we're also adding a random color texture node that gives you unique colors per object, layers, instances, sort of a high priority user request that we're implementing. The material and texture system, the material and shading system, we're adding 3 new BRDF models. One of them is an improved multi-scatter GGX, which will be energy preserving. Currently, the default BRDF, which we've had in Octane forever, is energy preserving. The GGX one isn't. Again, speed is key here, but we have a solution that makes multi-scatter GGX work just as fast as it does now. We're adding a tail blurring factor in the GGX shader as well. And then we have a whole new BRDF that's going to be used for fabric materials. So you're seeing here a beautiful scene rendered in Octane. These kinds of materials will actually render even better with the fabric BRDF, which is in development now. And yeah, I mean, obviously you can today do great stuff with Octane, but the goal with a lot of these features is to just make it easier and to make the quality even higher and to render even faster. On the post-processing side, there's a lot of work being done right now. Some of the things that are going to come in very quickly and up this year are fast fog. Users have asked for that, both as a post shader. It'll also be in the environment node as well. We're going to have a whole new post-processing stack, probably around Q3, which will have a complete revamp of the imager node, and we're going to have things like sharpening and all the things you're seeing here, contrast gain. There'll be basically a full Photoshop stack inside of the imager system. It will also be usable in the nodes, texture nodes themselves, so you'll be able to interchange post-processing and shader nodes. There's also a proposal for OSL to be used that way as well, so we're probably going to be adopting that. And most importantly, we're going to have essentially a compositing graph inside of Octane. It'll be a node graph. It'll really give you the ability to turn, if you want, Octane into a Photoshop replacement. Still, some people go to Photoshop after final render, and they do filters, and they do color correction, they do things here. We want to make all of that completely something you could do inside of Octane very easily in the existing node system, and not have to go back to Photoshop. So that it's going to take several different forms. You're seeing here on the very right is a compositing node. User requests have been asking for that for a while. It's essentially Photoshop inside of a node. You can take, you're seeing here, you can also take multiple outputs from AOVs and drop them into the compositing node live. Essentially, you see here, I'm actually doing multi-light, and I could take other nodes, and on the very left, there's the color keying node. You can mix all these things together. And truly, if we can make it so that you don't have to leave Octane or the host application to get a final render, that's a big time saver for artists and for users. So that's why these kinds of things are important. And of course, inside of this node, we're also adding all the different Photoshop blend modes and a lot more. You'll have everything that we can squeeze in there, from essentially the basic Photoshop pipeline in the compositing node system. But what's really cool is that as we add support for multiple AOVs and render passes in the compositor, you'll be able to do things really nicely in ways that were a lot more complicated before. For example, if you wanted to have a wireframe shader inside of Octane, you really couldn't do it. Here I am taking the wireframe pass though, and with the compositing node, I could just blend that live on there. So all these things are possible and easy to do. In the future, we're also going to be adding support for doing multiple concurrent rendering of multiple render targets and blending those in the compositor. And what's really nice is that with multiple hybrid render delegates, let's say you want to have Arnold's volumes or Brigade's volumes in Octane, you can blend those together as well. This will all work through the compositing node in the future. Along with that work around compositing, we have to do a lot of work that's been in development right now around the AOV system. We haven't really changed that in years. That's going to completely get revamped this year. We're going to support custom AOVs. It's been a long time coming, so you'll be able to set that up with shaders and with light path expressions, which are pretty important. And we're also adding support for driver passes. Again, this will be very similar to the to the Arnold driver nodes. They'll have the ability to send your output passes to a specific file format, and we're also going to support all the different compression options in EXR in the driver nodes as well. Longer term on post-processing, we want to have full render modules that do really interesting things that we're seeing being done outside of Octane right now by Octane users, like this one, for example, which is taking an AI style transfer filter, Deep Dream, done by a great art and artist, Ben Shapiro, who's also been using Render and a partner. This was actually using Octane with Deep Dream. We want to make that a standard node inside of the compositing pipeline. And other AI filters as well, like upsampling, temporal resampling is also there. We do have some of these things inside the imager node, but we want to make those part of the compositing stack. Rendering and motion sampling. So first up is the camera. We're going to be adding multi-region rendering support. Depth of field can be toggled. And we're also adding way more lens control in the universal camera. So the lens control that we're adding is going to support things like chromatic aberration, which is highly requested. You'll be able to do physically based lens flares as well. They'll be pretty fast. And another thing is optical zoom will support motion blur inside of the universal camera itself. And speaking of motion blur in general, we're going to be adding motion blur inside of HDRI environments. In general, we want to be able to support a full graph that can go into an HDR node or dome light. And we're going to be cleaning up other motion blur features that are currently limited, including volume instance motion blur and motion blur for objects that have texture displacement. That is currently disabled in Octane, but it'll be fixed this year as well. And we're also adding a time node. And this is something that I think from the simplest value proposition for users, you'll be able to do time shifting for Orbex proxies. That's been a highly requested feature. This will allow you to do that and also just create envelopes, warping, and all these time controls inside the node graph, inside of shaders. Super important. That's coming up probably in late summer as well. Our work in geometry is also pretty far along for new features too. So one of the most highly requested features that we're adding pretty soon is adaptive subdivision for vertex displacement. You can turn that on or off. You'll be able to freeze that, but doing something along the lines of screen space is important for users, so we're adding that. We're also adding full support for parametric splines and curves as primitives. And that will be in tandem with us doing the work around getting that to render faster in RTX. And we're also going to have geometry Boolean operations as nodes as well for meshes. That already works for Vectron, but it'll work for meshes with those nodes too. Some updates and feature improvements to coordinate mapping. Smooth tangents will work. This is also important for parallax occlusion shaders that we're adding. And it'll make anisotropic materials work better as well. And UVW packing from plugins. There's a limitation that we're addressing with UVW packing for compile primitives that'll allow you to more easily pin procedural textures to deform texture output that we were showing. Spectron is getting a bunch of new light primitives as well. A lot of these will also sort of follow the standard lights that Arnold's been using for a while. Already, Spectron does all those things for the lights it supports, but there's more that we want to add and make that sort of a standard thing, especially for scene conversion being an important factor for us. So Spectron parallel light, Spectron parametric spotlight will be added. This will be a little different than the volumetric spotlight we have now. And we're adding disk and tube light primitives as well. Those will, again, render much faster than the equivalent mesh light equivalent of that, or the emitter on a mesh. We are adding something, though, for mesh lighting, which will be a pure mesh light. If you just plug a mesh into this light, it'll render faster than having that mesh with an emissive material. So that's a new Spectron node. And we're adding a brand new portal light. They're portal materials, but this will be a portal light. It'll connect to a new Spectron dome light. It'll have flags that allow you to sort of connect HDRI and IBL settings, I guess, to these portal lights. So that's a highly requested feature. Those will connect together, and I think that'll work great. We're also doing some new features in light filters for Spectron lights. You're going to have light decay blockers that can be, I mean, internally we'll write that in OSL, we'll ship it inside of Octane Core, but you know, it'll be expandable. We're also building a full light manager, and we're also working on something called Spectron Scatter, which is going to basically be an instancing, a point instancer for Spectron point lights or point spheres. And you'll be able to write shaders that could do high performance particles with that. The reason why that matters is that currently these particles are driven by, you know, some sort of cache from the host application, or they're sent by the host application over the CPU bus. Not efficient. I mean, what we want is, just like with OSL, where you don't have to bake textures to get a shader in there, we don't want to have to bake particle systems. We can actually run those live at render time, drive them in shaders. That's great. So Spectron Scatter is going to be something that we do for that. It'll work with vertex shaders as well. For example, Touch Designer has GLSL vertex shaders. We are planning to actually fully support GLSL alongside of OSL as a core function this year. So you'll be able to take those things. Touch Designer, you know, shaders are awesome, so we want to support those shader toy as well. But yeah, the idea is that, you know, massive procedural particle systems, faster and lighter weight. There are slowdowns that you get when you're rendering with particles in a host application or driven by something outside of the rendering process. So moving more and more of these things into the renderer as open source OSL shaders becomes something that I think is going to create a lot of great efficiencies and speed and improvements as well. And that brings us to the next feature, which I think we're you know, going to be rolling out later this year, and we're excited about. That is Vectron displacement. So we currently have really interesting texture displacement, which doesn't require you to even, you know, use vertices or displace or tessellate anything. We have vertex displacement, which is doesn't have the same limits. You can actually use shaders, but it has to create unique geometry when it does that. So Vectron displacement, which you saw on the left there, let me restart the animation here. Basically, Vectron displacement takes the best of both. It's driven by Vectron 3D shapes, you know, or OSLs. You apply that to a mesh surface like you do with vertex displacement, but like with texture displacement, there is no unique copy of that mesh made. So it's the geometry is modified and generated live on the GPU, and you can do 1 million of these different copies, and they will not take 1 million times more memory. That will be the case if you're doing vertex displacement currently, and there are limits with texture displacement. So this basically gives you the best of both. You can also plug in a Vectron node into a mesh, and it'll just basically work, I mean, for those kinds of effects. But it just has a lot of value for instancing. and also supporting things like vegetation and skinning and other things that really should be done in shaders on the GPU. So Vectron displacement, I think, will be a wonderful artist feature. We're also going to be doing something called Vectron Scatter, and anyone that's used Octane for Cinema 4D has probably used Octane Scatter, which is a great system made by our Cinema 4D developer, Ahmed. And we're starting from that as a core node in Octane. You're seeing here all the features in that core node. It's going to be similar to what's in C4D now for Octane Scatter, but we want to do things a little differently. We want to make that work in the core so that we can eventually start to support new features and plug in other things that are inside of the Octane core system into that at a deeper level, a little bit like what we're doing with Spectron scatter nodes. So you'll be able to scatter across animated surfaces. You'll be able to scatter on Vectron volumes. Vectron doesn't even show up in a lot of host tools. We're actually working on that. But the idea is you can do very complex procedural GPU-based scattering at runtime, and that means no baking for scattering. That means the scatter can be infinitely complex. We can start to leverage GPU compute for these things, just like we've done for Vectron and itself in other nodes. We're also working on geometric Vectron scattering systems. For example, if you combine Vectron scatter, Vectron displacement, you can do something very similar to V-ray pattern, which is basically tileable geometry along the UV coordinates of a mesh for things like weaves and other things that can be done with meshes. So it'll support that. And we're also adding support for sparse volumes. So currently in Octane, you have to create a grid or a voxel grid, even if it's a VDB, to render. And what this will allow you to do is you'll have it essentially, your entire world will be very sparse volume, and you can then send shaders and do full procedural whirls, entire cloud or sky system in these sparse volume shaders. So we're calling it Vectron world shaders. We think that will be really great for just giant environments. I mean, there's a lot of people that want to do clouds and volumes and things like that. And Vectron volumes can do that, but the world shader will allow you to do that in even more expansive ways. So on the material roadmap, we also have other things that we're looking to support. OSL trace sets, which again, like OSL tracing in general, the trace function is not currently enabled, but we want to add that support for that and do that across the board. Open Color I/O is work in progress and will be coming up fairly soon. That'll also help with ASIS support. And material layer composition. As I was sort of saying earlier, there's a few nodes that we're going to be adding with material layers so that truly, if you wanted to do anything with OSL closures, the shader code, you could do it all with nodes. And I think that's ultimately where we want to be going for artists. But we will also probably be going back to doing OSL closures and taking another look at MDL, NVIDIA's material language system, and adding those into Octane too. And then there are things that we've always had on the Spectron roadmap, for example, fluorescence and phosphorescence, that we sort of pushed back just to get our priority user feature requests going. But what you're seeing here is actual builds of Octane that we could just merge with the current release. Polarizations is another one. And so we're probably going to end up doing that in the same release cycle that you're seeing a lot of these features that I've just shown. And we're also going to be making a major overhaul of what we support in the core of Octane as far as file formats. Currently, when you export or load files through Orbex packages, they're Limbics for the most part. We're moving that to USD, and we're going to make USD a first class citizen inside of Octane itself and the Orbex ecosystem. And that'll be fantastic because I think USD has truly become mature enough to make that work. You're seeing it adopted everywhere. And along that road, we want to look at what USD and the material system itself can support. So of course, with Octane supporting and fully baking in Arnold standard surface and standard volume, what's interesting is that if you have a USD file with Material X, which is a material graph that we're also looking at supporting USD, we'll be able to have a pretty robust scene interchange format, even short of Orbex, but we want to, at least make that something that can be loaded and used across the various standalone and proxy systems in Octane. And of course, Hydra is a really big part of our future roadmap. I mean, building Hydra into the core of our rendering system, of which now Octane plugs into, is key to getting multiple renders and rendering going in all the GTC tools out there. I've shown this before. There's some new updates to be done with anime rendering. We call it an anime kernel, for lack of a better term. It's something we're going to be adding in Octane, as well as probably building a separate standalone Hydra render delegate that can be used just for toon rendering. But it does do very fast ray traced line rendering, which you're seeing here. And you need that. Edge rendering is its own thing. You can't just completely do that in a material. You need to actually do outlines and do tracing in a different way than normal rendering supports. So this kernel is designed for that. It's all in real time. It does leverage hardware ray tracing, gives you these beautiful results, and it's something that basically works, in real time on one GPU. So if you're doing toon rendering, the results are fantastic. I think this is actually rendering at 4K, even though it's scaled down, of course, for this presentation. But toon rendering is something we really want to take another deeper look at, and this anime kernel is a big part of that. We have another feature that we're working on for later this year. It's still very early, but it's basically progressive photon mapping. So and it's a PPM kernel, so it's a whole new kernel in Octane, essentially a whole new rendering path. And the reason why we're working on this and why it's important is that it'll give you amazing results for caustics. And we want that in Octane. Right now, there's two ways you can do caustics in Octane. On the left, you're seeing a scene here that's using gobos with very clever shaders to give you caustic effects. It's very fast, but it is not accurate. It is not real caustics like we're doing on the right, which is using our PMC kernel, which is slower, but it gives you very accurate caustics. So the idea with progressive photon mapping, and this is a hybrid mode, it'll basically do photon mapping for caustics, and it'll mix that with your path tracing or direct lighting kernels, is you'll get the best of both of these. You'll get very fast caustics, beautiful caustics that are as good as what we do with PMC, but it'll happen much faster. And this is, I think, something that a lot of Octane users will be able to leverage and take care of and utilize. So we're excited with that. It's probably one of the earliest in development features out of all the things we've just shown. But once we're done with it, it'll also have another set of uses. So having photon mapping allows us to do things like a diffusive radiance cache. We can basically do biased rendering options with photon mapping that we've developed for the caustics kernel. And you can do biased effects. So if you want to ever think about having radiance caching in Octane, it'll be an option. And this actually is going to be used by us for real time. So Brigade, our real time rendering system, we want to have essentially all of the GI in AR, let's say running on an iPad, be cached so that it just renders faster. And I'll be showing how that works with Brigade on an iPhone in a little bit. But this PPM kernel is part of the process of making that standardized. And also, I mean, there's a lot of discussions around whether biased or unbiased rendering really is better. And the truth is, you want both. I mean, you're seeing things that make sense in one workflow or another. So the goal with this is really to give Octane the ability to have more biased options. It has always had biased rendering with the direct lighting kernel. You can turn on AO. That's obviously a biased mode. But just having more options is not something that I think any artist is going to be mad at. So extending beyond rendering, the features in Octane are going to be done by render modules. And we were showing Embergen effects, but truly there are a lot of categories besides simulation we want to support. And some of those are touched on by first and third party modules being done in render right now that we're looking at. And physics is an important one, soft body and rigid body. So we've actually, inside of for Octane users, what they'll see when we add this render module inside of all the current Octane plugins is you're going to have soft body and rigid body physics. We're actually building in PhysX and Bullet as backends to this system. You can switch between those, just like you can essentially switch renders. We've used Bullet in the past. This is in Brigade, actually, from a while back. It's great, and it's essentially going to be built into the node graph. So if you have standalone scenes that you want to interchange, you'll be able to set these properties in the objects and drive the rigid and soft body simulations through these backends. That also means that we can extend that to third parties that have much more advanced simulating tools. And that can be things like TFD, which is a very popular plugin that works alongside Octane. That could definitely be a render module, and we work closely with Josset on that. One of the other great modules that we're looking at is called Storm Granular Solver. This is a render that was done with Octane and Storm together. It's beautiful. And what we want is that right now, again, like a lot of tools, there's a standalone version of Storm Granular Solver, but we want to plug that into turn it into a render plugin. And we've talked to the developer about that. And that will probably be something we develop after Embergen effects and other tools are ready. But again, having this work inside of your DCC tool of choice is great. Now I want to talk and focus a little bit on how Hydra works with render modules inside of this system. So, you can imagine, of course, all the things I've just shown kind of working with, Octane, as, an Octane plugins. But really, going forward, all those 20 Octane plugins for the DCC tools that we have for C40 and the like, are not going to be just Octane. They'll essentially be Hydra render delegate consumers. And what's interesting is that there are tools like Blender that want to have Hydra support, and that's a long-term roadmap thing. But what will happen is that Octane for Blender, when it has Hydra support through this new API, will be able to load any Hydra render delegate into Blender. Same thing with Unity or Unreal. And instantly partners are working with like Arnold. You'll be able to take Arnold rendering and bring that into Unreal or Unity. Any of the Octane plugins will be able to load in Hydra render delegates, and of course, Octane itself is a Hydra render delegate, and there will be extensions in the render API to really cleanly handle materials and scenes and all that stuff. But again, having Solid Angle and Autodesk validate that this path works for both Octane and Arnold is great. And Brigade is also going to be a render that we are going to ship using this path. So people have asked, how is Brigade as a separate render going to work? Well, it'll work essentially as a swap-in Hydra render delegate across all the different plugins that currently are Octane only. So that's great. And that also explains why we're eager to support standard surface, so that can become essentially our default system across multiple Hydra render delegates. You can also, as I said earlier, composite them together. And the other thing is we can also, essentially Octane's API, we're calling the render API, can operate as a Hydra scene delegate. But other tools can extend that further. And that's how we see things like Sculptron also connecting into the system. It is possible, by the way, for us to take things like Eevee or Cycles or the Unreal Engine and feed them backwards through the system so that you can actually turn these apps that are open source, like Unreal and Blender, both of which we've actually done this test with, or Unity, and turn them into render delegates for Hydra that can run through this system. And you can actually have render delegates for these other renders go through the system as well. So it's very powerful. Obviously, this is a little bit down the road for us. But I think the immediate use case for other render delegates besides Octane is Brigade. Brigade is completely like Octane X built in the Render SDK. What we're showing here is actually running on Vulkan, and of course we work on Metal. But Brigade is completely designed around real time. We've had Brigade in development for ages. I think this is 2015. We're showing this running on 80 GPUs. This is roughly about 3,000 Octane bench. But what's amazing is that we can get to 3,000 Octane bench equivalent for these kinds of scenes with RTX, with ray tracing hardware. And we've been pushing NVIDIA to add even more ray tracing hardware support in their GPUs just so that we can make Brigade run even faster and better, which is what you're seeing here. And Brigade last year at 2019 was kind of simple. I mean, we had basically very fast ambient occlusion. If you ever used Octane, this is instant, right? This is instant AO. For a split second there, you saw sort of an early version of GI. And that's kind of where things were at last year. But this year, Brigade 2020 has full path tracing on RTX. And left is Octane, 4 samples per pixel running on a 2080 Ti, same as the render on the right in Brigade. But the Brigade one it's very clean. It's noise free. And the reason why it's noise free is that it's a completely rebuilt kernel. We do simplify the BRDFs and material system in Brigade a little bit, even though it's sort of a simple switch from Octane. You don't have spectral rendering and some other things we do. Actually, by automatically converting all materials to Arnold standard surface, which is going to be the default in Brigade, things are even more optimized and faster. There will be an Octane as well, but ultimately, just as you can see here from comparing live rendering, there's just no difference. I mean, path tracing in one versus the other, it goes from being near real time, which is important, and you do get something that is absolutely pristine quality with Octane, to something that's pretty close to pristine quality with Brigade here on the right, but is running at 60 frames a second. It's just incredible. So a lot of the value of Brigade, even for Octane users, and being able to flip that on, is the similar thing that Eevee brings to Blender and Cycles. And frankly, this is our version of Eevee, I guess you want to call it that, but I think it can go much further. I mean, unlike Eevee or even hybrid renderings, things which are rasterization plus ray tracing, this Brigade it's just like Octane. It is fully path traced. It is not using any rasterization. We wouldn't be able to load scenes like Forest and other things if we were to do hybrid modes like that. That's still a limitation for game engines and things like Eevee. So Brigade is pretty much the same capabilities that Octane does in terms of scene complexity and loading. It's obviously much faster. And we are taking all of the Octane code that we built for Vulkan and Metal, and that's going into Brigade. So you are getting identical BRDFs in cases where we want to support that. The other thing that's awesome about Brigade, again, consider that Brigade volumetrics could just be added to Octane, but even if you're just doing 100% of the rendering in Brigade as a render module, volumetrics are basically instantaneous. They're also instantaneous in Octane, but they're not this noise free. So you're seeing God rays that are just basically running game engine speeds on a single 2080. And lights, Spectron lights, Brigade, absolutely awesome. Look at that. You've got caustics, which are essentially real time, very fast, and volumetric caustics, which are super, super hard to do fast, high quality, real time. They're running completely natively in Brigade at full speed. This is ray traced depth of field inside of path trace, actually depth of field inside of Brigade. You can see you have beautiful bokeh. Pretty tough to do that at this speed for path tracer, but that's part of one of the great features Brigade is integrating. And these things are all, I mean, there's no bias rendering here. It's all path tracing, just like Octane path tracing kernel. We had some AO modes, didn't even bother showing. They're not any faster and they don't look as good. But one thing we are adding in Brigade is a connection to the PPM kernel output that I showed earlier, right? Basically a radiance cache, baking, if you want to call it that. So being able to run Octane in the background to bake GI, for example, as well as caustics, feed that into Brigade is valuable. One thing we were able to validate is how this would work last year when we were showing these tests, which basically show Brigade running with, actually at that time it was just versus supply inclusion, but all of the GI doesn't even need AO because all the GI is coming from Octane's ambient occlusion, radiance cache pass. And this is how it looks when it's rendered. It's nice. It's very nice. You can't really change the lights like you can in full Brigade mode, but when you're talking about bringing Brigade with the radiance cache to AR kit like we're showing here, then you see the value of this. This basically is how these scenes, which are full 3D scenes running on the Octane X, which will include both Octane and Brigade rendering systems. Brigade with the radiance cache is beautiful, and you need that kind of quality for AR kit. You don't want any noise. You don't have RTX hardware on an iPad, so this matters. Now, this is really useful for anything you want to do in AR. It's frankly also kind of useful for anything you want to do in real time. I think Brigade's fast enough to not need any sort of radiance caching on the desktop, but I think for mobile and AR, there's some value to that. And it also does ensure one thing, which is anything you still maybe want to do in Octane that you could bake, that's spectral, could be actually, if it's expressible in GI or caustics, could still be brought into Brigade or even other renderers. And that is something that we want to start thinking about as well, more as we look at ARKit and AR in general. This is showing some of those same scenes running in Octane and iOS. Octane iOS will have at least 3 modes. It'll be what you saw earlier with the Octane path tracing mode. Brigade will be another mode, and then Brigade with real-time rendering, GI cached and radiance caching, and the ability to pull in lighting from the scene. All these things are why our footprint on iOS, the iPad, and phones is really compelling for us. And this a scene here showing how we can take ray trace lighting from the scene in real time. ARKit does struggle, with the API, right, giving you things that are live. This is showing live ray tracing, the best we can do live from in camera, running on the iPhone for AR. It's really cool. And so we've been sort of showing these things for a little bit. They're experimental, but as we get Octane X out there, and we have Brigade in there as well, and we have these modes supported, the pathway towards doing this high quality AR will be really simple from any of the toolkits that we support in Octane. And we've also tested that with animated geometry as well. This is an animated scene. And the goal is that with Octane X on the iPhone, there's a lot of things that people have done where they take things that attract to the camera. This is on the right, a C4D scene, HDRI, the Atom Unity asset. And one of the Octane users posted this, and it got 10 million views. It went viral. Done on a desktop. What we want to do is we want to make it so you could do this on your phone, all from within Octane on the iPhone, right? Because you already have camera tracking error built in live. GI radiance caching or not, which I don't think we need in all cases, you'll be able to do a lot of authoring on the phone itself. So, that's something that is exciting, simpler, better for artists, and probably a whole new ecosystem for Octane users. And with Octane itself entirely running on mobile devices, there's a lot we can do. And of course, we still will support connections back to high-end GPUs on the desktop or the cloud. I want to talk about Sculptron, which I touched on briefly before. Sculptron is out as an alpha in the last few months as a separate tool. It's going to become a full render module, so you'll be able to use it directly inside of Octane as a tool that can edit and sculpt and do all sorts of things. The alpha, as you can see here, running sort of in the standalone version, it enables you to do temporal sculpting. There's a lot of sort of holes in the DCC pipeline today where things that involve temporal keyframing and sculpting are just not that simple. And also, we want to have the ability for you to do things with Spectron and Vectron that right now just don't show up in the IPR viewports for a lot of DCC host applications. So Spectron is meant to give you that sort of solo mode editing and rendering. Right now, it's sort of an external application, just like Ember GenFX is going to be, and the Store Granular Solver are. But the idea with the render module porting process is this will be a no-step process inside of Octane. The nodes for everything that we do in Sculptron and other things will just become pieces of the Octane ecosystem. So Sculptron Alpha 2 is going to be out very soon. It has a whole new timeline and keyframe system, which is great. Whole new UI and workflow, much easier, I think, on artists to use. And see here, it's also 10 times faster than the first alpha. So again, everything that Sculptron is doing is done on the GPU. We're not doing much on the CPU. It's a GPU tool, just like OctaneRender rendering. And the idea is that you have much faster sculpting and procedural workflows enabled through this system. We're also adding new viewport modes, so you're going to have things like a tune-based matcap in Sculptron's viewport, wireframe. But of course, Brigade is going to be our viewport of choice when you're doing anything in real time. And we have an ambitious roadmap for Sculptron as well. I mean, right now it's designed mostly for sculpting, but we eventually want to have it be a full editor for USD. Remember, we're adding Octane support for USD. That's really going to be inside the render SDK. So Sculptron as a scene editor has a lot of value. We want to have it so that, again, if you don't have to go to a DCC app to get something that Sculptron can provide in the core, then that's great, especially with a free version. We're building a full mesh modifier stack, GPU-driven, a little bit along the lines of what I was showing with Vectron displacement. And we're going to have layout and other tools. We're going to have painting tools for scattering and other things. We're going to have the ability to write OSL shaders for the mesh modifier stack. And the other thing that I think will be helpful with Sculptron is doing forces and fields. So the scattering tools that we've been showing before are going to benefit from having a built-in authoring system that can work with that. And we want to integrate that in the viewport of every DCC tool that we can. This is the long-term roadmap for Sculptron. It is huge, and there's a lot of great stuff on there. But this is further out. But we're posting that and sharing that roadmap with everyone so people know where the tool's going and what to expect from it as we keep adding more and more features to our stack. So now I want to talk about holographic rendering, which I touched on at the very beginning of this presentation. And going back really to my GTC talks from 2015, I was talking about the holodeck, how to build it, when it's going to become real. And it is exciting to sort of see the pieces of that come together. And I was predicting that really the 2020s would be the decade when this would all sort of come together. 2014, we were showing off a software solution that we felt was fundamental, which was light field rendering out of Octane. And light field rendering is a cheat. It basically renders all the rays of light from an Octane scene as a giant set of rays you can then look up, which is showing here. Simple texture lookup. We built a codec for it as well. But the texture is like a hologram. You can look at it from any angle. And this was also great for real time. I mean, if you want to go a little bit deeper faster than Brigade and Radiance caching, right? You can just take 6 polygons that we're showing here and deliver a fully real-time, beautiful experience that has no geometry overhead whatsoever. So it's even faster than Brigade's system. However, Brigade can load these 6 polygons and render it. And so a light field shading system is going to be part of Brigade. But there is another important factor for developing all this technology. And that is we are going to see something like the Star Trek holodeck come together this decade. So this is one of my favorite clips. This is from the first episode of Star Trek: The Next Generation in '87. Counter at Farpoint. Character goes into a room. The room is the 6 walls, like what I was showing before, but each wall is a holographic display, and the character feels like they're in that environment. There's no AR or VR or tracking. It just works, right? And that was something that Gene Roddenberry imagined was going to be hundreds of years in the future, but it's not. Lightfield Labs, which is a company we partnered with, and great news on that front. They just received a lot of funding. They've got $28 million in funding from major investors like Samsung and others. They're building holographic display panels, and we have an exclusive partnership with them. We're building everything else on the software stack, the pipeline stack, to drive that. over the next few years. And the panels themselves are pretty exciting. I mean, they basically are no different than what was in that Star Trek episode. You can look at these panels and you're seeing essentially a white light hologram and emissive hologram. They're going to be constructed in these 2-foot by 2-foot segments. So like the Samsung video wall that you might see at CES, you can make any surface size you want. You just have to connect more of these together. So you pay essentially by the square foot. And the first adopters are really going to be theme parks, things like concerts and so forth and so on. So this is how it would work if you're seeing it in a concert. I think one of the greatest form factors for these displays that's going to be most useful for our users are tabletop holographic display panels. They are working on touch support, by the way. So you'll have haptics. And you don't need to have a room-sized holodeck to make something really useful out of these panels. I think surfaces like a table are immensely important for creation and design and work and even interacting with objects. But if you do have, $10 million, you can build a room. You can have curved versions of these things. They can go on the floor and the ceiling. So that's what these panels do, and that's where things are heading. As far as developing for these things, we had to sort of start out with not having. We still don't really have more than a couple of prototype panels to work with. Most of those are up north. We're in LA. So we developed a system that started with basically just tracking your head and your eye, which we're doing here, and then coming up with a way to take our light field rendering system and put that onto a panel that we can then check out how our light fields work. But truly, the light field output that we've been doing for this kind of sped up rendering is something that we want to apply to these displays. The displays themselves are just massive. They're about a gigapixel per square foot, 32K by 32K. This is a better version of the test, something we've shown at SIGGRAPH, where we have head tracking with a Vive tracker on a baseball cap and shutter glasses, so we don't have to close one eye, so we can actually see what the light field display would be doing with test scenes, and it's pretty close. I mean, it looks like this, except what I'm seeing here is really shot through the camera with tracking, but of course, you can have a million people in front of this thing, and they'll all see a slightly different view on the real holographic display. And this is the testing, the one I was showing actually earlier in Brigade versus Octane. This is the mini metaverse scene by Javier Leon. It's on the display panel. The floor, as I sort of mentioned in previous talks, is on the surface of the display, and that door and the coat hanger are above the surface, and it looks insane. It just looks real. I mean, you can take magnifying glass, ground glass, and look at these objects. What we've done in the last year, though, since my last year's talk, is we do have Brigade outputting to the display panels in real time. We can run these things at 10 or 15 frames a second on a single GPU, but it does take 15 RTX 6000s to drive one of these display panels at 60 hertz. We need more ray tracing cores in future RTX cards to make Brigade run even better, but we can also just blast the light field output that we've been doing for purely offline, non-real-time stuff to these display panels. So we have those two modes, and they're both useful, but Brigade as a real-time system is able to drive these displays live. It's just not at the frame rate that we want yet, but it's getting there. The panels themselves, this is a nice graphic to sort of show how they work. The prototype panel, we've been working with 6 by 4 inches, plug more of them in there. The further you go out in terms of surface area, the further out objects go in and out in terms of their holographic volume. And it's pretty amazing. And I do think that there's so many use cases for this kind of technology. It'll become cheaper as well, which is why we have high hopes for this being adopted. There's a case to be made that if this works, you may not need VR or glasses. I mean, I think glasses are a thing of friction. I mean, there's a reason why you don't have shutter glasses, or 3D TV at the home didn't work. AR sort of struggles with that too, although I think AR has a lot of value when you're walking around outside. Indoors, having holographic display panels is going to make a lot of sense. And so looking ahead 10 years, I think holographic display panels will become a commodity. I don't think there's going to be any reason. I mean, Samsung's an investor in light field lab, right? Why wouldn't every single Samsung display not be holographic? So, these things are going to come down in price just like all screens do. I mean, television screens and 4K and all that have become, and even 8K, they become commoditized, and they go down faster out of all consumer electronics than anything else. And that's going to happen for holographic displays as well. You're going to see windows, I think, replaced with holographic display panels as well. Certainly cars, things like that. If you have self-driving cars or an airplane or a boat, you might just have the entire outside sort of be filtered through a holographic display panel. And I think also just having, if you're staying indoors, having a display panel that can look like a window could be amazing. I keep thinking about the use case for people on the space station or on Mars or whatever. Eventually, having something like this really will change the way you feel indoors. And I think that, in the 2030s, you're also going to see people invest in So they invest in home theaters. You're going to see home-sized holodecks. Why not? It may be expensive at the start of the decade, but by the end of it, it might be really cheap. And a decade after that, it'll be like wallpaper. I mean, you'll start to see holographic displays everywhere, and the future generations, even in the 2020s, will have 2 bidirectional recording. So you'll be able to record holographic content and spit it out the other side. So you'll have telepresence, really nicely handled. And I think telepresence will just be completely everywhere through holographic display panels. I mean, just like we have now with video chat, this will just be much better. It'll be the best of Skype and Zoom and all these things, and VR and AR just mixed together in a way that just feels really human, and that's important. Clothing and wearables will probably also become holographic, so you'll be able to actually put anything you want on what you're wearing. It'll look interesting. You can also probably have masks and other things that could be there to give you any sort of face you want, which is another interesting use case. I think another one, just thinking about how cities of the future might look, is to have, I mean, you see now LEDs actually going on clothing to some degree as well, but also buildings, right? You have entire surfaces of buildings that have LED panels and displays on them now, but if you had them be holographic, it wouldn't just be necessarily to have holographic displays or billboards or ads. You can actually make those buildings invisible. You can change the way cities look and make it look like there's no city at all, or make the buildings look completely different and real. And that's a fascinating application of this technology at scale. And that's where we see the future going. There's so many different things that we are seeing driven by the revolution in GPU rendering, the cloud, and everything else. But one of the things we strongly believe in is open standards and an open ecosystem. I mean, the web has been fundamental to creating the value of what we see today in the technology space. And we want the metaverse, however it happens, to be open as well. And a lot of the work we're doing around Orbex and partnering with others like Autodesk around open standards and everything else related to this, even Render itself and the way it's been designed philosophically, is to come up with a way to make the metaverse itself built on open standards and fight for that as much as we possibly can. And I love the idea of being able to mix and match the talents and skills of programmers and artists and content creators and companies all around the world, just like the web has done. We need that in 3D. We need that in this future. And OTOY is there to help make that happen any way that we can. So that's it. Thank you, everyone. And I'll see you at GTC next year in 2021. This is Jules Roback, signing off.